today we're going to pull back the curtain on a piece of tech that honestly feels like straight up magic, but it's something you use every single day. It's one of the most powerful forces shaping our world right now, so let's dive right in.
I mean, just think about it for a second. You pick up your phone, you look at it, and boom, it's unlocked. It's so seamless. It's kind of spooky, right? How in the world does a machine know who you are? Well, the answer isn't some secret spell. It's science. And to be specific, it's a really powerful kind of AI called deep learning. This is the engine that's running not just your phone's unlock, but so much of the smart tech that we now take for granted.
Now, to really wrap your head around deep learning, you have to start with its original inspiration, which is that incredibly complex supercomputer sitting right between your ears. So what is it really? At its heart, deep learning is all about teaching computers how to learn from examples. The really cool part is how it does this. It uses a digital structure that's actually modeled after the neural wiring of our own brains. And this brain-inspired structure, well, it's built out of something called an artificial neural network, or ANN for short. Okay, but let's be super clear here. When we say inspired by, we do not mean it's a copy. Not even close. Our brains have living biological neurons, the result of millions of years of evolution. An ANN has digital nodes, and it's a much, much simpler model that humans designed. It's kind of like comparing a paper airplane to an actual eagle. One gave us the idea for the other, but they are worlds apart. So if it's not a real brain, how does this digital version actually, think? Let's follow the data and see how it works. So any piece of information that goes into the network takes a journey through three main stages. First, it hits the input layer, where all the raw data gets fed in. Then it travels through the middle part, the hidden layers. This is where all the real analysis happens. And finally, it reaches the output layer, which spits out the final answer. That input layer is basically the system's senses. If you give it a photo, this layer doesn't see a dog or a cat, it just sees a giant grid of pixels, every single dot and its color. It doesn't understand anything yet, it's just taking in the raw information. Now this is where the deep learning comes from. It's all about these hidden layers. The first layer might just spot simple things like lines, edges, and basic colors. But then the next layer takes those simple patterns and learns to recognize more complex shapes, like an eye, or an ear, or a whisker. And the layer after that puts those shapes together to recognize a whole face. Each layer gets progressively smarter, building on the work of the one before it. And after all of that complex analysis, the output layer boils it all down to one simple, clean answer. It takes everything it's learned and just makes the call. Yep, that's a dog, or access granted. But wait a second, how does the network even know what an eye or a whisker looks like in the first place? Well, here's the thing. It doesn't start out smart at all. It has to learn. And just like us, it learns by making tons and tons of mistakes. The whole learning process is called training, and to do it, you need data, a lot of data. We're talking about feeding the system millions of pictures that have been carefully labeled by humans. This is a cat, this is a dog, this one's a cat too, you got the idea. So imagine you show the network a picture of a dog. The first time, its internal wiring is basically random, so it takes a wild guess and says, cat? Then we show it the correct label. Nope, that's a dog. At that moment, the network knows it messed up. And here's the absolute genius part. The network figures out how wrong it was. Then it uses this clever mathematical trick called backpropagation to send a little correction signal backward through all those layers, slightly tweaking every single connection. The goal is simple. Make it just a tiny bit less likely to make that exact same mistake again. And you just saw the key. It does this over and over and over again. It guesses, gets told it's wrong, makes a tiny adjustment, and moves on to the next picture. And it does this millions, sometimes even billions of times, until its guesses get freakishly accurate. So, after all that incredible training, what does this stuff actually do for us in the real world? Well, as it turns out, it's pretty much everywhere. It's already woven into the fabric of our digital lives. That facial recognition on your phone? Yep, deep learning. When you talk to Siri or Alexa, their ability to understand you is powered by deep learning. You know those online translators that are getting scarily good? Deep learning. The recommendation engines that tell you what to watch next on Netflix or what to buy on Amazon. You guessed it. It's even the foundational tech that helps self-driving cars see and understand the world around them.
Now, if there's only one thing you take away from this entire explainer, please let it be this. The truly revolutionary thing about deep learning is that we humans don't have to write code telling the computer how to find a cat. We don't program rules like look for pointy ears and whiskers. No, instead, the network figures out those patterns all by itself, just by looking at the data. This amazing ability is its superpower. It's called automatic feature extraction. The machine identifies what's important on its own, and that's why it can solve problems that for decades we thought were impossible for computers. So from something as simple as unlocking our phones to something as complex as driving our cars, this brain-inspired AI is completely reshaping our world. And that leaves us with one final, pretty mind-blowing question. If this is what machines can learn today, what on earth will they be able to learn tomorrow?